Good day, sir. So today, I will be presenting my final project for our subject, Data Structures and Algorithms Laboratory. So in this presentation, I will explain how each part of my code works, show how the tree structures is implemented, and then demonstrate the actual execution of the program. After the explanation, I will walk through the output step by step so you can clearly see how the binary tree behaves as downlines are added and commissions are computed. So the instructions were very specific and I strictly followed all of them by separating my program into three files. So first is the header file, which contains all necessary structures, declaration, and function prototypes. The second one is the implementation file, which all functions are defined. Lastly is the main file that serves as the interactive menu-driven interface. Now that I've introduced the project, let us take a closer look at the code implementation. I will begin with the header file. So this is my header file, mlm_network.h. So inside this file, I declare the node structure, which represents each member. The structure contains the member's name, their commissions, and the two pointers representing the left and right downlines. So the header file also contains all the function prototypes used in the program, such as create member, add downline, search member, compute commission, display downline, and display network. So later on in the implementation file, I will explain what are the purpose of those function prototypes. So that's all for the header file. Now let's proceed to the implementation file. After knowing the structure and function prototypes in the header file, the next part is the implementation file, or the mlm_network.c. So this file contains the complete function definitions that make the system work, including create member. So this function allocates memory for a new member and initializes their commission and children. Next is the search member. So this recursively scans the binary tree to locate a member by name. It is used heavily when adding downlines and displaying downlines. Next is the add downline. So this follows the binary tree rule. If the left child is empty, put new member in the left. Else, if the right is empty, put new member in right. Else, sponsor already has two downlines, it prints confirmation and success. Next is compute commission. This checks every node in the tree. If a member has both left and right downline, they earn 500. It then recursively updates the whole network. Next is the display downlines. This prints the left and right downlines of a chosen member. Lastly is the display network. So this is a pre-order traversal that prints the entire network along with each member's commission. Now that I've shown how all the core functions like creating members, adding downlines, computing commissions, and displaying the network are implemented in the implementation file, the next step is to actually put this function into actions. This is done in the test file or the main.c. Here is where everything comes together. The program starts by asking the first member as the root of the network, then presents a menu for the user to interact with. Every option in this menu, adding downlines, computing commission, displaying downlines, or display the network, calls the function we implemented earlier. So while implementation file handles the logic and the header file handles the structure, main.c is the interface that allows the user to test and experience the program. Essentially, this is the part of the program where all the functions from the implementation file are called and tested in real time, giving the user a fully functional and interactive experience. This is where the code comes to life. Now I will demonstrate how my program works. When the program starts, it asks the user to enter the name of the root member, which is the first person in the network. So I entered my name, Sheena. This means I am the very first member and placed at the top of the binary tree, and every member I add will branch out under me. So next, I will add downlines under me, so I will choose option 1. The program will ask for a sponsor. I will put my name because I want to add new member under me. Then after that, I will enter a new member name, which is Risa. Then Risa will be successfully added as my left downline. Now I will add another downline under me, so I will choose option 1 again. Then I will input the sponsor name and the new member, which is Ricky. So Ricky is now added as my right downline. At this point, I have a complete left and right pair, which means I will qualify for a 500 commission. Now I will compute all commissions according to the rules, 500 for every complete pair. So I will choose option 2. Then, the program recursively scans the whole binary tree and show every member's commission. After this step, the commission values are now accurate based on the current structure of the network. As you can see, I'm the only one who has a 500 commission because I'm the only one who recruited 2 members. But of course, Ricky and Risa can also add 2 members in their downlines, but I didn't do it now because it takes time. Now I will choose option 3 because I want to display the downlines of a specific member. To verify the structure, I will display the downlines of Sheena. So I entered my name Sheena. As you can see, the program prints the downlines of Sheena, which is the left side is Riza and the right side is Ricky. This confirms that my downlines were stored correctly. Now I want to display the entire network, so I will choose option 4. So the program prints the entire network together with the member's name and their corresponding commission. So this is the complete multi-level marketing network shown in pre-order traversal. The program clearly shows each member and their commission. I earned 500 because I have 2 downlines. Riza and Ricky have no pairs, so their commission remains 0. This confirms that the binary tree and the commission rules are working correctly. To end the demonstration, I will now exit the program. So I will choose option 5 to exit the program. That ends my program output demonstration. Thank you so much for watching.